Welcome to the deep dive. Today, we're jumping into something that, well, affects everyone. Rising greenhouse gases and, the planet getting warmer.
Mm,
The basic science isn't really up for debate anymore. It's happening. Humans are the main cause. But what's really interesting, and maybe a bit worrying, is how much we don't know.
that's right, especially about the finer details, the full dynamics of these gases.
Yeah, the intricate dance, as you put it.
And, a lot of the really critical questions, we can only answer them by measuring more, doing more experiments all over the world.
And crucially, as our sources point out, a lot of that needs to happen in developing countries.
Exactly. That's where some of the biggest unknowns are.
Which brings us straight to the core problem. This kind of research, carbon and GHG research, it's historically needed really advanced kit.
Super expensive instruments, yeah. And proprietary software, specialized technicians.
The whole package, it's a massive barrier, basically. Creates a kind of scientific divide.
It absolutely does. And the result is this really stark mismatch. You have the regions most vulnerable to climate change.
Like drylands, tropical forests, places vital for the global carbon balance.
Precisely those places. And they're the least researched because the resources just aren't there.
We're flying blind in critical areas.
Pretty much.
So, okay, if the traditional ways are too expensive, too complex, how do we fill this gap?
Well, that's what this deep dive is all about. There's this really ingenious concept emerging, appropriate technology and approach, AT&A.
AT&A. I like it. It sounds practical.
It is. It's not about cutting corners on the science, not at all. It's about being smart.
Using low-cost instruments, maybe simpler tech.
Yeah, that. And championing open source software, open data, getting communities involved through participatory research, building networks.
So kind of a clever workaround, really.
A very clever and necessary one. So today, our mission is to unpack these global blind spots we've mentioned.
Dig into why they exist.
Right. Then explore these AT&A solutions. What are they? How do they work?
Look at the pros and cons, the potential pitfalls.
And finally, sort of map out a path forward. How can we foster global collaboration to really boost this research where it's most desperately needed?
Sounds like a vital conversation. Let's
Yeah.
get into it.
Okay.
So we've touched on these global blind spots, this imbalance caused by the traditional way of doing things. But let's really underline why a global view is so critical here. Why can't we just rely on data from, say, North America and Europe?
What if you zoom out, understanding carbon and how greenhouse gases move between the land and the atmosphere? It really has to be global.
Because different places are different.
Completely. Developed and developing countries have different sources, different sinks places that absorb GHGs. Their vulnerabilities to climate change vary massively.
And their capacity to deal with it, to mitigate or adapt.
Exactly. So it's just not a one-size-fits-all issue. You can't just extrapolate data from one region and assume it applies everywhere else.
Which leads back to that traditional research dilemma. Getting good long-term data or data covering huge areas, it's just incredibly expensive.
Right. To develop, to implement, and crucially to maintain long-term, many developing countries simply can't foot that bill on their own.
Meaning they rely heavily on international collaborations.
Which unfortunately can bring its own set of issues. Our sources talk about this thing called helicopter research.
Helicopter research. Sounds like what it is.
Pretty much. External researchers fly in, set up equipment, collect data, maybe involve local scientists in a limited way, and then fly out.
Taking the data and often the expertise with them.
Often, yeah. And these projects frequently don't guarantee sustainability. So when the funding ends, the research stops. It hinders local scientists from continuing or building on that work.
That seems like a huge barrier to building local scientific strength. We saw that example, didn't we? The Southeast Asian peatlands.
Yeah, that's a really telling case. Globally critical ecosystem for carbon storage.
Massive carbon stores.
Huge. But out of 80 published GHG studies there, something like 65%, nearly two-thirds, were not first authored by local researchers.
Wow. So the local scientists aren't leading the research in their own backyard.
Which leads to these critical data gaps. It makes it incredibly hard for these countries to build their own accurate national GHG inventories.
Which they need for reporting, and more importantly,
For developing their own mitigation strategies, ones that actually work for their specific situation. It's like trying to manage your national budget without knowing where the money's actually going.
Let's talk specifics on these data gaps. Carbon pool quantification, for example. How bad is it?
It's pretty bad. Accurate data on how much carbon is stored, say, in forests, and how that changes over time, it's severely lacking in many places.
Especially the tropics.
Especially the tropics. Get this. 84 out of 99 developing countries in the tropical zone reported their forest carbon pools using default IPCC values, meaning they used generic global average numbers. Tier 1, they call it, instead of country-specific data, which is Tier 2, or even better, repeated actual measurements on the ground, Tier 3.
So they're using a rough estimate instead of measuring their own reality.
Exactly. Think about the uncertainty that introduces into our global climate models. It's like trying to balance a global checkbook with huge chunks missing.
And the geographic spread of actual measurements, like for GHG fluxes.
That's incredibly skewed too. While global soil CO2 flux measurements, for instance, did increase quite a bit between 2000 and 2016.
Okay, some progress.
Some progress, yes, but the vast majority of those measurements happen in just a few countries. Developed countries, plus China, account for over 60% of global GHG flux measurements.
So where are the big gaps?
Africa and South America are critically underrepresented. Europe, North America, Asia, they cover maybe 90% of the observations.
Despite Africa and South America being hugely important for the global GHG budget.
Hugely important. And then you get to the really high-tech stuff like eddy covariance or EC.
Right, you mentioned that. That measures the breathing of an ecosystem.
Sort of, yeah. It measures the exchange of gases like CO2 between the ecosystem and the atmosphere very rapidly, incredibly valuable data.
But also very complex and expensive.
Extremely. So by 2015, only about 23% of the world's different types of ecosystems, ecoregions, had actually been sampled using EC.
Less than a quarter.
And again, the gaps are where you'd expect. Africa, Oceania, outside Australia, South America, very poorly sampled. In 2018, all of Africa had maybe 11 active EC stations.
11 compared to...
Over 450 globally around that time.
That is a stunning gap. Entire continents practically invisible to this key measurement technique.
And the knock-on effect is huge. It means all our sophisticated models.
Earth system models, machine learning, remote sensing products.
All of them. They likely haven't been properly validated or tuned for these environments because the ground truth data just isn't there.
It's that garbage in, garbage out problem again. If the input data is weak or missing for vast areas,
the model outputs for those areas, and maybe even globally, become highly uncertain.
Okay, so we see the gaps. What are the absolute root causes? You mentioned cost.
Cost is massive, yes. But it's also technical expertise and infrastructure. You need reliable power, internet, specialized technicians, ways to transport sensitive equipment.
Things that are often lacking or unreliable.
Or take a very long time to get sorted. And even when there is international collaboration, you still have those issues we mentioned. Local researchers may be playing limited roles and the research just stopping when the project money runs out. No long-term sustainability.
And access to knowledge itself.
That's another big one. Even with more open source stuff becoming available, you still need reliable internet to access it.
Which isn't universal.
Far from it. Plus, subscription fees for journals or training courses can still be prohibitive, even if things are improving with open access. And sometimes it's just a lack of awareness that these free resources even exist.
A digital and information divide.
And finally, you can't ignore the basic socioeconomic realities. When a country is hit by, say, a severe drought or major flooding.
Climate-related emergencies.
Exactly. The immediate crisis takes priority, understandably. Long-term investment in climate research, like measuring carbon, just falls down the list. The costs are too high compared to immediate needs.
It's a tragic cycle, really. Vulnerability hinders the ability to gather data needed to address that vulnerability.
It is, which is why we desperately need different approaches.
Which brings us neatly to the solutions. Unpacking this appropriate technology and approach, AT&A. Let's dive into that. What's the core idea?
The core philosophy is really about being pragmatic and resourceful. It means using instruments that are low cost, maybe lower tech, but still effective.
Making it accessible.
Right, and really leaning into open source software and data, making everything as open and shareable as possible. Plus, involving people directly.
Participatory approaches.
Exactly. Citizen science, community involvement. It's not just seen as a temporary fix either. It can be a crucial first step, a way to build skills and capacity, maybe leading to wider tech adoption down the line.
Building from the ground up. Makes sense. Okay, let's get concrete. Give us some examples. How does this work in practice? Say, measuring biomass, carbon, trees, forests. That sounds tough.
Traditionally, yeah, very laborious, measuring individual trees, often in really difficult terrain.
So how does AT&A help?
This is where participatory research or citizen science is fantastic. You can train local community members, people who know the area, know the trees.
They collect the data.
They can, very accurately, with the right training and protocols. It empowers them, makes them part of the science. There are great examples of this working really well.
That's really powerful. Okay, what about soil carbon? Equally vital, I imagine.
Absolutely. And again, challenging. Measuring soil bulk density can often be done locally, but for the actual carbon content, there are some neat low-cost options, like a field portable reflectometer. Basically, it shines light on a soil sample and measures what reflects back, which can be calibrated to estimate the carbon content.
And that's affordable.
Relatively, yes. One study mentioned hardware costs around USD 350, and it provided good, accurate estimates in places like Malawi, a real game changer for getting field data.
Wow, $350 versus potentially thousands for lab analysis. That's huge. Okay, I have to ask about the tea bags. Organic matter decomposition using tea bags.
It sounds a bit funny, doesn't it? But it's brilliant.
How does it work? You just bury tea bags.
Essentially, yes. You use standardized, commercially available tea bags, specific types, usually green tea and ribos, because they decompose at different rates. You weigh them, bury them for a set period, dig them up, dry them, and weigh them again.
And the weight loss tells you.
Tells you about the decomposition rate in that specific spot. It's cheap, it's standardized, anyone can do it almost anywhere. It gives scientists comparable data from all over the world.
That is genuinely clever. Using something ubiquitous. Okay, moving up from the soil to the canopy photosynthesis, plant health, structure. That sounds high-tech.
It can be, but there are lower-cost ways too. LEDs, for instance.
Light-emitting diodes, like in my phone screen.
Exactly like those. They can actually be used as simple light detectors that are sensitive to specific colors or spectral bands.
How does that help with plants?
Well, plants interact with different colors of light differently depending on their health, how much photosynthesis they're doing, things like that. So you can use pairs of LEDs, maybe red and near infrared, to pick up these signals.
And infer things about the canopy.
Yeah, things like canopy photosynthesis rates, phenology, like when leaves emerge or fall, even leaf area index. It's been used in grasslands, forests, even rice paddies using the blue part of the spectrum.
Repurposing everyday tech. What about just cameras? Digital cameras are everywhere now.
Another great example, simple digital camera images can give you a surprising amount of information about the canopy structure.
Like how dense the leaves are.
Exactly. Phenology, gap fraction, leaf area index, even leaf angle distribution. And the sensor in a cheap digital camera, the CCD, it can basically function as a simple 3-band spectroradiometer.
Measuring light intensity in different colors.
Right. You can get smartphone versions for maybe $20, $30. Incredibly useful for monitoring crop status, for example, in places with limited resources.
Truly democratizing data collection. Okay, let's broaden that again. Can we monitor the air itself? CO2, methane concentrations with lower cost gear?
Yes, definitely. There are studies successfully using low-cost sensors for exactly that, monitoring atmospheric concentrations.
And the fluxes, the movement of gases between land and air.
Also seeing progress, low-cost sensors paired with low-cost chambers have been shown to be effective for CO2 and N2O fluxes.
And even the high-end stuff, eddy covariance. Any cost reductions there?
There are developments. People are testing middle-cost CO2 and water vapor analyzers, maybe 15% to 25% of the price of the top-end ones, and finding pretty similar performance in some cases. Plus, using low-cost data loggers, cheaper meteorological sensors alongside them. It's all about finding ways to bring the cost down without sacrificing too much quality.
It seems like hardware is one piece.
Yeah.
What about data itself?
Mm-hmm.
Satellite data, remote sensing.
Mm-hmm.
Is that becoming more accessible?
Hugely so. This is a really positive trend. The remote sensing community is increasingly moving towards open access data.
Like Landsat.
Landsat, MODIS, the European Copernicus Sentinel satellites, incredible resources providing data for free.
What kind of information can you get?
Things like gross primary production, basically, how much plants are growing, land cover change, wildfire maps. Often these data products are provided directly, ready to use.
And specific greenhouse gas satellites.
Also becoming more open. Satellites like Japan's GoSat, NASA's OCO-2 and OPO-3, China's TANSAT, they provide crucial data, especially in those undersampled regions we talked about.
Filling the gaps from space.
And it's not just satellites. Ground-based measurement networks, big international networks like ICS in Europe, Ameriflex in the Americas, NEON, LTR, They are increasingly sharing their data openly too.
So a growing mountain of free data, but you need tools to analyze it, right?
Absolutely. And that's the other side of coin. Open and free code, software, and tools are booming.
Like R and Python.
Exactly. Powerful statistical software and visualization tools available under open licenses. Open source GIS software too. QGIS, GrassGIS, fantastic alternatives to expensive commercial packages.
And specific tools for GHG research.
Yep. Things like EdiPro for processing eddy covariance data, OneFlux for standardizing data. These are community developed and freely shared.
What about the computing power needed? Processing huge data sets can be intensive.
That used to be a massive barrier needing access to powerful servers, but cloud computing is changing the game.
Like Google Earth Engine?
Google Earth Engine is a prime example. Also Microsoft Azure, Amazon Web Services. They offer immense processing power accessible through the internet.
Still costs money, though.
It can, but costs are coming down. And there are often academic programs or grants that provide access. It removes the need for institutions to buy and maintain their own expensive high-performance computing clusters, provided they have decent internet.
And tools for sharing the analysis itself?
Yeah, things like Jupyter Notebooks or R Markdown make it really easy to combine code, results, and text and share them collaboratively. It fosters transparency and reproducibility.
Okay, so the tools and data are increasingly available. That leads us nicely into making it all work. What are the big advantages of AT&A beyond just saving money?
Well, the biggest one is probably the expansion of knowledge itself. You start getting data from places you simply didn't have it before.
Filling those blank spots.
Exactly. Even if the data quality isn't perfect initially, it's vastly better than having no data at all. And it makes sharing knowledge easier, democratizing science.
And the community involvement piece.
That's huge too. Citizen engagement. When people participate directly in research in their own environment,
They get invested.
they get interested, invested, they start applying that knowledge in their daily lives, sharing it with others. It builds climate literacy from the ground up.
And technically, it makes things easier to handle locally.
Yeah, simpler instruments are often easier to build, definitely easier to buy, operate, and maintain locally. It reduces reliance on external specialists for every little thing, lowers the running costs significantly.
Which could catch the eye of policymakers.
Hopefully, when they see tangible local research happening, generating useful data about their own country's resources or emissions, it can really increase their awareness.
Make them more likely to prioritize this kind of research in national policy.
That's the goal, encouraging investment in science and education related to climate change.
Okay, sounds fantastic.
Hmm.
But let's put on our critical hats. What are the challenges, the potential downsides or pitfalls of AT&A?
Well, we have to be realistic. Data quality is a key one. Generally, data from low-cost instruments will have higher uncertainties than data from top-of-the-line advanced instruments.
So more noise in the signal.
Potentially, yeah. You have to be aware of that and account for it. Then, with participatory research,
It's in science.
right, there's a potential for bias. Participants might not fully grasp the scientific protocols, or maybe sometimes they might have a self-interest in the results. It needs careful management and clear protocols.
So training and oversight are crucial.
Absolutely. And if you're relying on a network approach, lots of people collecting data, it might not be useful if the overall collection plan isn't really well thought out and managed. Consistency is key.
And AT&A doesn't solve every technical problem, right?
No, it mitigates them, but it doesn't eliminate them. There will still be situations or specific measurements where a low-tech alternative just doesn't exist yet. Technical capacity remains a challenge.
Okay, so knowing these challenges, what are the smart ways to deal with them? How do we ensure the research is still robust and the data useful?
Quality control is paramount. If you're using low-cost sensors, you absolutely must monitor the data quality constantly. By cross-checking, validate the low-cost data against measurements from more advanced, reliable instruments whenever possible. Maybe run them side by side for a period. Use robust data processing software.
And the experimental design itself.
It becomes even more critical. Because you might be dealing with lower accuracy or precision per measurement, you need to compensate.
Oh, more samples.
That's one way. Careful consideration of sampling periods, sufficient replication, taking multiple measurements, designing smart network sampling strategies, and then using the right statistical analyses to properly account for errors and potential biases.
Rigor in the design to make up for potential limits in the tools.
Precisely. And for the participatory part, having really clear, well-prepared, easy-to-use protocols is essential. Everyone involved needs to understand exactly what they need to do and why.
Communication and clarity are key.
Definitely.
This brings us to a really interesting idea from the sources, this trade-off between uncertainty, time, and cost. Can you unpack that a bit?
Yeah, this is a really useful concept for planning research, especially with limited budgets. Basically, achieving a certain level of confidence or reducing uncertainty in your findings involves a balance.
Yeah.
Imagine you have a fixed, maybe small budget. You have choices. You could use a super accurate, expensive instrument for a very short campaign.
Get high-quality data, but only for a snapshot in time.
Exactly. Or you could use a less accurate, cheaper instrument, but run it for a much longer period.
Gathering data over seasons or even years.
Right. Which might be more valuable for understanding long-term trends, even if each individual measurement is less precise. You'd likely need to put extra effort into quality control and validation with the lower cost option, though.
So it's a strategic choice depending on the research question and resources.
It is. With a tiny budget, your uncertainty might be high regardless. But as the budget increases, you gain flexibility, more accuracy for short periods, or longer monitoring with lower accuracy methods but careful design. It shows there are different paths to impactful research.
That's a really empowering way to look at it. It's not all or nothing. You can make smart choices. Okay, let's look to the future then. Fostering AT&A through global collaboration. What's the ideal picture here?
The ideal model, really, is integration, bringing all these pieces together.
Low-cost tech, open data, open software, community involvement.
All of it, integrating them strategically. Because when you combine them, they can compensate for each other's weaknesses.
How so?
Well, maybe low-cost sensors provide continuous temporal data, while periodic satellite data fills spatial gaps. Open software allows everyone to process the data consistently. Participatory approaches ground truth, the remote sensing. It creates synergistic effects.
More than the sum of its parts.
Exactly. And this integrated approach reduces overall uncertainty, fills more gaps, and, crucially, makes the whole effort more sustainable. It also allows local scientists and communities to take on bigger, more central roles, building that vital local capacity.
A true win-win. So how do we promote this? What are the key strategies?
First, we need to demonstrate its value. Show practical applications where AT&A provides useful, actionable results across different fields. Increase the demand by proving it works.
Success stories breed success.
Pretty much. Second, funding. We need diverse funding opportunities, but critically, they need to think long-term. Not just funding a 2-year project, but thinking about supporting the infrastructure, the data collection, the capacity building beyond that initial phase. Sustainability is key.
Avoid that helicopter research problem again.
Right. And third, awareness, training, education. This is foundational.
Have it boost that.
Scientific conferences, workshops, training sessions specifically focused on AT&A methods and tools, but also integrating it into regular university curricula. Science fairs for schools, student clubs, using public media, social networking like that at AT&A4 GHG initiative mentioned to just raise general awareness.
Mainstreaming the idea.
And collaboration seems absolutely central to all this.
No.
It's non-negotiable, really. The sources strongly emphasize that the success and long-term sustainability of AT&A depend deeply on active, genuine collaboration between developed and developing countries.
But with a crucial difference from the old models.
Yes. The scientific communities in developing countries must play the primary leading role in defining what they need, what approaches make sense for them. It has to be driven by local priorities.
Not just externally imposed projects.
Exactly. It needs to be a true partnership.
And there are benefits for everyone involved.
Absolutely. For developing countries, it's a practical way forward getting crucial data and building capacity within their constraints. For developed countries, it provides invaluable new measurements from undersampled regions, which helps improve their own advanced models and applications.
Fills the global data gaps we need to fill.
Right. And it also stimulates R&D into new, better, low-cost instruments, which benefits everyone. Plus, it just aligns with where science is heading anyway, towards more open access, more data sharing.
So it's about fostering a new kind of partnership, more equitable.
That's the heart of it. Developed country investment is still vital, no question. But much more attention needs to go towards the priorities set by developing countries.
Ensuring real transfer of knowledge and skills.
And assuring the activities are actually sustainable on the ground long term. Promoting open data access and, crucially, the use of that data in academic programs everywhere is vital.
And developing countries have a role too.
Of course. They also have a responsibility to increase their own investment where possible and to really foster collaboration within their regions at the continental level, perhaps. It's a shared responsibility.
What a journey through democratizing climate science. So just to recap this deep dive, appropriate technology and approach, AT&A, it really offers this powerful way to bridge those critical research gaps in carbon and GHG science,
Yeah, reducing the economic burden, making it feasible.
and really empowering local communities and scientists to be central players in this vital work.
And the key takeaway, I think, is that it's not just about using cheaper stuff. That's part of it, sure.
But it's more strategic than that.
Much more. It's about a thoughtful, integrated approach. It demands careful experimental design, really robust protocols, constant quality control, all to make sure the data you get is actually useful and has long-term impact. It's about being smart with the resources you have.
Being effective and impactful. So here's something for you, our listener, to think about. Imagine how this model, this focus on accessibility, collaboration, local empowerment, could reshape things beyond just climate science.
Yeah, it has broad implications.
Right. Think about other critical global challenges, public health, agriculture, conservation, where getting good, equitable data on the ground is paramount. Could this AT&A philosophy fundamentally change how we do science globally?
Could it truly democratize scientific progress across the world?
Something to ponder. Thanks for joining us on The Deep Dive.